I don't think many people realize that this, without the little creatures that are like 1 nanometer in diameter, that life on Earth would be impossible. Well, the problem about this, another thing I'd like to mention is the CO2. The exchange with the atmosphere, or the exchange between the atmosphere and the ocean, is at the surface of the ocean. So when you've seen these pretty cross sections of the ocean, it's going in at the surface. So this is where the ocean is being changed. And this is precisely this thin little strip, if you will, of real estate is also where all of the organisms that rely on light to produce their shells and their carbon matrix live. So it turns out that when David was talking about the pteropods, it already looks like we've gone close to the edge of the cliff, as it were, with regard to the pteropods. The saturation levels, or the level in the ocean, you could think of it below it, or a little deeper. These things dissolve above it, they might be happy. In the North Pacific Ocean, okay, just south of Alaska, this has been squeezed up to the point where they have about 80 meters of water column. If you go to the Atlantic Ocean, it's 1,500. So they could live all the way down to 1,500 and not be in undersaturated water. And it further, some Australians did some experiments in the South Pacific where there are some isolated areas that have very low saturation states. In other words, the shells or the houses that these guys live in are basically being eroded and corroded. They're labile, and they're being torn apart, okay? And they're already seeing major and substantive losses in average shell weight in the South Pacific, which is an area of the world that I had never imagined would be shifted that quickly. I think, many of you say, well, hey, so what about the little guys? As it turns out, in the North Pacific Ocean, the people that have looked at the diets of salmon, so if you take a look at pink salmon, they rely on pteropods. And in 1999 and 2000, when they took a look at the food types that the pink salmon ate, 60% of the salmon diet was made up of pteropods. Okay? So as these guys start to go, I don't know anybody smart enough in the world to predict what the ocean's food web is going to be like. And for those of us who love salmon, and I had it the last 3 nights, we might have to get along without it. Okay? So it's, to me, it's a sobering thing. And Dave talked about coral reefs. Florida has probably billions of dollars a year in tourism. Think about Australia with a coral reef that's probably close to 2,000 miles long. They have already, there's been a report in Science in which they've seen a dramatic drop in the growth rate of the coralline systems. They sampled 288 varieties. Okay, and since 1990, there's been a precipitous drop in the growth rates of these major corals that form that system. In any case, these problems, and I'll end up with this, are not just limited to the open ocean. Okay, if you take a look at Casco Bay, Maine, this is a major oyster area, and the pH, thanks to I guess it's the Casco River. I apologize, I can't think of the name of the river, but if you take a look at the pH, you contour it, you can see that there's a plume associated with this river that's incredibly acidic, that's actually starting to interfere with probably $100 million a year industry. Okay, what about the west coast of the United States? Okay, along the entire west coast of the United States, you get upwelling of cold, low pH water. How low is the pH? The pH that was given before about the scenario in the ocean was like 8 or 7.9. The pH of some of this water is 7.6. So pteropods don't live there. They can't live there. And the point is that in Willapa Bay, which is probably the biggest shellfish industry in the whole west coast of the United States, it's not clear that this $100 million a year industry is going to last, because there's a cycle to the upwelling events along the west coast. They've increased it in intensity since 2001, and they're having a lot of trouble there because they can't predict when that cold, corrosive water is going to move in from the outer shelf and hit the oysters. So the point is, I think we're starting to see some of the major shifts, if you will, in the societally relevant and important food stocks that are a part of our society, and especially with regard to the open ocean. That does actually, to me, is sobering. Forget about the temperature change. I'm sorry. You can argue about that. You can get people to argue with you. What you can't argue about is acidification. It is a relentless, unforgiving process that's going on right now, and it is by far the most serious challenge, I think, for us that we've ever seen. I mean, I can see a North Pacific Ocean that's full of jellyfish, open ocean. Not a lot of them, but they would replace the pteropods and the other carbonated species. Thanks.